Well, welcome everyone to the Hive. Thanks for joining us. Can I just have a quick show of hands who have been to the Hive before? And those who haven't? And those who haven't put their hands up? There shouldn't be any. So it's good to see so many people have been to the Hive before. This is a little slightly different format than the presentations we've had here before. Essentially, David here's on holidays at the moment, and he thought it would be better to have just an interview style rather than a presentation as such.
I didn't have to work up PowerPoints or anything like that for you
guys.
That's
right. So that works. Except you've got me on stage this time as well. Let me introduce David Newman. He is Senior Director of Software Engineering at GoPro.
Yep.
But he's also a graduate of Curtin. Did a Bachelor of Engineering in Computer Systems, isn't it?
Electronic and Communications Engineering.
Okay.
That's what it was called then.
Yep. David and I were both going through the same department at that time, and we've stayed in touch all of those years. It's been a sort of an interesting pathway from.
We mainly crossed over in the image technology group with
correct, that's right.
Tom Doherty and
yes.
Harry Edgar, I guess.
Correct.
Yeah.
So one of the first memories was you were working on a oscilloscope simulator.
Yes.
Was that a final project or a?
I don't remember. I'm sure that was actually no. It was a class exercise. It wasn't my final project. My final project was actually in video capture. We had I was working with a team that were building a video capture board. It was still frames, not from a video source. And even though my degree was focused on the hardware side of things, I already worked out by that time that was too difficult for me. So I focused on the software side to control a capture board and wrote software to do the image development and to allow for controlling saturation, contrast, and basic color correction, and did that as my sort of major project at the end.
So that was your beginning of your path into the video.
Yeah. So I always knew that I wanted to be involved with content creation. I had taken, during my years at Curtin, had taken a couple of ski trips to New Zealand, and we would buy duty-free our first cameras, and we would just go out and be early GoPro. And in fact, we were trying to shoot ski videos, even though neither the friends who went couldn't ski. We were trying our best to create content and realize how difficult this was. And so, so the very first engineering project I got involved with outside of Curtin was working with the very first nonlinear video editing products. And these were essentially motion JPEG capture boards. They would capture a series of JPEG frames. It was only standard definition. And it was really before there was quite the term nonlinear video editing. Avid, which dominated in this space, hasn't even around at that point, or was just forming. And so I was working on writing video editing software that would allow you to do the real-time edit and dissolves and titles and all the things that we see now as commonplace, but do it from a desktop computer. And that was back in 91, 92, 93 timeframe. And so there wasn't a model to follow because computer-based video editing just didn't exist. Everything was still tape deck to tape deck. And we worked writing software that controls tape decks so you can actually perform an edit from an edit decision list and actually make, but that was boring, and that was something that as an individual I couldn't do. I couldn't use that to make my ski videos. I wanted it to work on my desktop computer. So my whole career has been doing that in one form or another.
Yep. So shortly after graduating, you migrated to the US. What was the circumstances around that?
Well, I was working. Yes, I was working as a contractor for a local firm that was writing software to do video editing. There was a company in north of San Diego that was producing a card, and they were writing their own software, and it was mainly for what they called animation recording. All of station promos, they used to have all these rendered animations, and to play them out to tape, they would use these animation recorders. And we had taken one of these boards to turn it into a video editing board. And I managed a group of 4 engineers, and the short version of the story is the guy they wanted to send, not me, to help out in the US to showcase this piece of hardware. We were invited to, it was called the Broadcaster Elite, and it was made by a company who I was one of the early engineers on, called Applied Magic. And they wanted us to help show how good their board was, as being another vendor that was supporting it. And they wanted to have some help finishing the product. And the engineer who was supposed to go was hired because the guy here had discovered his name in the newspaper as getting involved with hacking into, I don't know what the telephone company was at the time. And he thought, oh, he must be good. He's got this hacker spirit, so we're going to hire him. And it turns out if you hack a government-owned corporation, that the US declares you a terrorist. So he was 17 when he did this, and he couldn't get a visa to go to the US. So I only had 2 days' notice to say, well, we need someone who knows this. And I was sent to the US. I had to learn his software on the plane and then start coding like crazy when I hit the shores there. And while I was there for 6 weeks, the company here went bankrupt.
Oh.
So they weren't paying me anymore. And they said, well, can we hire you? And so they got me a visa. And so, yeah, with 2 days' notice, I'd sort of been in the US ever since.
That was Applied Magic at that stage?
No, the company that went bankrupt was the one that was here. That's why I'm not going to mention their name.
Oh, okay.
Yeah,
No,
they
but
were employing me. No,
the one you end up working for, was that Applied Magic, or was that a bit later?
Yeah.
Okay.
It's hard to say. Applied Magic was formed around the same time. There was another company that was building hardware, and they had a new idea about what they wanted to do, and they formed Applied Magic. And I was one of the early engineers at Applied Magic, and eventually grew to be the CTO at Applied Magic.
So you were there for 7 years?
Yeah. So for a startup, I've had a lot of long-term startup roles. And yeah, we started with a Commodore Amiga-based video editing system, and it was really good, but of course Commodore Amiga went away, so it was very hard to sell that. And then we decided to build this product called Screenplay, and it was an embedded video editing system. We designed everything. I mean, other than we actually even made an ASIC for it, but we designed our own operating system, we designed our own file systems. Crazy endeavor, a lot of fun for an engineer to build this thing. And it was you plug it into your television or any monitor, and it had a RF remote, and you could edit your videos on the TV. And that was the concept. And it sold very well into education markets where you didn't want to learn a complex tool. You know, Adobe Premiere was coming about, and Final Cut didn't yet exist. But those tools were still incredibly complicated, and they were non-real time. And this was a real-time video editing box. It was too expensive because of the hardware, and it didn't grow as fast as what was happening in the PC market. PCs were doubling in speed every 18 months, and we had built a hardware product that was awesome when we first came out, but it started to age. And we realized we needed to respin ASICs, and $2 million for every ASIC that we built that did all the graphics processing. I got involved with chip design, which is something that I hadn't had any training in, but I knew what the architecture I needed to perform the kinds of video effects that we wanted to do and what we needed to do in real time. Built the Screenplay, and then Applied Magic didn't actually fail. It just ended up becoming a sales organization. And because we had these great ideas, and we realized, well, computers have come fast enough that inside the Pentium processor at the time was this MMX core, this multimedia instruction set, that we realized that is the DSP now. That is the high performance video engine that we need. We can do everything that we've talked about doing in software. So when we founded Cineform, which was founded from the engineers from Applied Magic, so really it's like it was an evolution. We got new VC funding, and we made an organization that says, we're going to solve consumer video editing, but do it on real-time video editing, because we realized the consumer did not like to wait for rendering. That was, and we're going to solve this using off-the-shelf compute hardware. So we would just be a software company. And that was the vision. It didn't turn out that way, but that's what we intended to start. The funny thing is that vision is much closer to what we now do at GoPro.
So Cineform started in 2001.
Yep.
Was it the video editing, or was it the codec that was...
Well, yeah. We started with this vision that video editing needs to be easier. And the first thing we found the problem was that all the compute resources were taken up with decoding the compression technology that was coming from the cameras. Either people were using MPEG-1 or MPEG-2, which was either MPEG-1 low quality, MPEG-2 compute intensive, or they were using DV, had just started coming out, which is this cassette format that was digital. It was a DCT-based compression. But what we've soon worked out is all these compressors were not designed for the computer environment. They were designed to make it easier. It was all about silicon. It was all about silicon real estate. The reason that DCT, discrete cosine transforms, are dominating in video compression today, everything from MPEG-1, MPEG-2, H.264, which is everywhere, HEVC, they're all DCT-based compressions. It's easier to put in silicon. So it's not about the convenience for the user, which is going to use it 100 times more often than the acquisition. It's all about the convenience for the camera manufacturers. And so what we realized, the reason people couldn't do video editing in real time back in 2001, 2002 timeframe, is the codecs were killing the compute performance. So we didn't intend to be a codec company. We designed the Cineform compression to solve a customer problem that it turned out to drive our business. Everyone loved it. You know, we thought, let's just make this simple. We designed it around the architecture of Intel processors. We worked out what would be fast on an Intel processor, how. And we also, because of my experience with building Screenplay, we used a wavelet chip there, and I loved the quality of the wavelets. In compression, there's two camps. There's wavelet and DCT. Wavelet is used in JPEG 2000, which you may have encountered. But when you get artifacts, it looks soft, it looks a little blurry. And as a result, people don't see it. They're used to seeing the little ringing boxes and the contouring in the sky, and they don't see it. So we could get away with higher compression than our competitors could, and no one would notice the artifact. So I love that, because if I'm going for a consumer market, I don't want to eat up a lot of disk space. But it also had a nice artifact, is that if you increase the bit rate, it never had any macro blocking or edge artifacts, which means the professionals loved it. So we ended up being, even though we had this vision of making video editing possible for consumers, we ended up finding that we were servicing Hollywood and feature films and everything wacky in the world of feature content creation. So
Yeah, so it's been used in a wide range of feature films as well.
Yeah, and it's because, and strangely, the most common use case is IMAX. Because even when they were still shooting IMAX film and they were scanning the IMAX negatives at like 8K, well, what are you going to store that in? An uncompressed 8K frame. And a frame is 152 megabytes or something crazy like that. And then if you're doing 24 frames a second, and IMAX sometimes run at 48, and just the burden of data is massive. And IMAX films have limited budgets. I mean, they're not, you know, if a film makes $10 million as an IMAX film, it's a blockbuster. So they can't afford to even store their film. So they needed to look for a compression solution that would preserve the quality, because IMAX is the premium in quality, and we're the only one, even today, you know, practically. So we still use the IMAX features, 2D and 3D. We're places like Photocam, they convert everything into Cineform, and they run it around, you know, for IMAX around 10:1 compression, and very happy about that.
So Slumdog Millionaire was also one of the high-profile films that was shot with that.
This came from a different form, because Slumdog Millionaire was acquired into Cineform format. So we were working on making post-production easy, and it turns out what it also enabled was computer-based capture easy. So Slumdog Millionaire was filmed with a little camera head called the Silicon Imaging 2K. So it was the first, you know, it was beyond HD. And because we weren't one of the standard codecs, we weren't limited by standard resolutions. A lot of the codecs that existed today, the compressor decompressors codec, were limited to 1920, 1080, or certain frame rates, or stuck and interlaced, like one or two of these cameras are. You know, these weren't what filmmakers were wanting. They wanted to emulate film. They wanted 24p, they wanted larger sensors, and they wanted higher resolution. And so we had this ability to compress the image. So Slumdog Millionaire was shot with this camera head with a lens, an Ethernet cable, going into a backpack, running a Mac laptop, running our software to compress the images. And because it was filmed through the streets of Mumbai, they would constantly run and fill the backpack with dry ice so that the laptop wouldn't overheat. And then the cinematographer, Anthony Dodd Mantle, dressed up like just a crazy-looking tourist, so everyone would just ignore him. So they didn't have to get permits. They could shoot anywhere throughout the city, and no one knew that he had all this compute gear. And but and it was just, the camera just looked like a little bit bigger, like a Hasselblad or something like, a medium format camera, but it could totally look like a tourist. And that's how they shot a lot of those. And so it ended up about 70% of the movie, almost 90, all the digital acquired material was shot using Cineform compression this way. And because they were planning just to shoot the street scenes, and then the director loved the look of the images and found them very organic and not digital. That was the thing that we had achieved, is not getting a digital look to these images, and which is a lot to do with the camera and some to do with the compression. But and so we had started sort of the early revolution of what is now digital cinematography, because previously cameras were, they were 3-chip, that was considered the professional. They had three CCDs and a beam splitter, and a blip, to break up the RGB light and encode it separately. But that prevented the lenses getting bigger and getting to the sizes that they used on film. And once you could compress a large sensor image natively in the original sensor format, and that's what we invented at Cineform. And then we've seen that world explode, and now single image, large sensor is the commonplace.
So Cineform also had a range of video, I guess, plugins for Premiere and some other packages as well. What was the nature of that?
Well, we were, because we were a compressor and we provided a codec, we realized actually there's no money in compression. And we were a startup, we wanted to make income. And the need for plugging into things like Premiere is because while we had the ability to do real-time effects and things, because the codec was faster, we needed to make sure the on-ramp and off-ramp into the codec was seamless. And so we ended up having to build out the full ecosystem for the users. So we didn't sell, here, buy our codec. There were people who were saying, here, buy JPEG 2000, and they would sell the codec for $40. Instead, we would say, here's a plugin for Adobe Premiere, and it emulates a real-time video, like a plug-in in a $2,000 card, so we could sell it for $1,000. Software for $1,000 was a great deal. It gave you the performance that seemed like a great deal, and we made good margins because it was software. And what ended up happening was a lot of, we were always on the right side of certain infighting that was happening. Apple had the first success with Final Cut Pro being used to edit the film, I'm trying to remember it, Cold Mountain, Renee Zellweger. That was the first film that was edited on a desktop computer. And Apple made these big promotions about it. But if you've actually researched what they did, it was an offline, which means they just edited a rough draft, but then they went to the expensive 200K Avid system to finish it. So, and of course Microsoft didn't want this. So we've got to work out how to be the first desktop finished film. And it turns out there wasn't any technology that was available. So Microsoft goes to Adobe and says, do you have anything? And they go, no. And Adobe and Microsoft ended up investing in Cineform to make sure that we had, and so we did a film called Dust to Glory, which is a documentary about an off-road race in the Baja, California. And it was one of the most complex. It's a 24-hour endurance race for motorcycle off-road vehicling. And they had 260 hours of source material over this 24 hours. They had 55 cameras, all different resolutions, all different frame rates. And there was no way, and it's a documentary, I mean, it only had like a budget of $2 million or something like that. There's no way they could have finished this in a traditional form. So their story was, this film wouldn't have existed unless it had a digital intermediate, and Microsoft claimed it was their, part of their technology. I mean, it was just the operating system, but it was really between Adobe and Cineform, we made Dust to Glory, and that was our first feature, and that set all the different. And the people who made Dust to Glory went on to make Act of Valor, which was one of the biggest, very low budget but huge earnings, and then they just did Need for Speed, and that's all Cineform. So they've been convinced ever since.
I'm working in 3D for a long time, and I was very pleased when I saw you and Cineform were working in 3D. What was the circumstances behind that?
Well, we were trying to make sure that we had some technology that people would buy rather than just compression. And so we modified our compressor, still the only one in the world that does this, that allowed you to change the way the image developed. So we figured you're shooting these raw cinema cameras, which gives you a wider dynamic range, and it gives you a flat, unappealing look. So the first thing people had to do was color correct it. And we go, well, there was a lot of mistakes being made. One of the things that Cineform liked to say, well, I certainly did, is we fixed the mistakes of camera vendors. And that's how we made our living, is camera vendors made mistakes all the time. And so we wanted to make sure that we could control the image development. And this was used on Slumdog Millionaire. It's a way that we can instruct through metadata, so it was non-destructive, the way an image would develop. And someone who was researching doing Tron Legacy saw our published white papers on this and goes, can you modify that for 3D? Because the guy who was going to edit Tron Legacy, at that point, all 3D feature films, the 3D was not done during the editorial, it was done during the finishing, which means the editor only ever saw it in 2D. And then it was a different person who did a different, who did the convert, who did actually and this is just a mistake. I mean, clearly an editor should see the content he's creating, and so this editor says, I'll only edit Tron Legacy if I can edit it in 3D. But I want to edit in Final Cut Pro. And Final Cut Pro today still doesn't natively support 3D. So we modified this active metadata color development engine to do 3D, to handle 2 views. And we actually planned for multi-view. And create 3D assets that you could do the fix alignment and as part of the active metadata. Got it working and did it in 6 weeks. We thought, oh, this is exciting. I mean, I was a total geek. I thought, I can be involved with making the follow-up to Tron. That's such
Classic
a great
film, yeah.
Yeah, and do it properly in 3D. And we didn't think there was going to be any money because you sell one license to someone like that. You know, it was purely the geek factor, and we would have to wait. We couldn't tell anybody until the film was released, which would be like 2 years later that it was using this technology. Well, the editor got fired from the project. And so we didn't know the new editor. And so we'd done this work, and then a big trade show called National Association of Broadcasters, which is the massive film content and TV production trade show. And we thought, well, we might as well, what do we call it? Neo 3D. What do we price it? I have no idea. Turns out we could have priced it whatever we liked. It sold like crazy. And this I'll segue because it's how the GoPro introduction happened. So meanwhile, in another parallel world, the CEO of GoPro and his chief creative director named Brad Schmidt apparently had dinner with the CEO of Red Bull. So you get the sort of the circles that GoPro mixes in, and the CEO of Red Bull, they're very much a media company. They produce a huge amount of content, and they knew about NAB. He says, if you go into NAB, this is 2010. If you go into NAB, you have to have 3D. This is the year of 3D. Everyone's got 3D. And so they hot glued 2 GoPros together, no sync at that time. And seriously, there was a hot glued thing on their booth there. And then Nick is a total auto fanatic, so they filmed him doing illegal stuff in a car around some back roads around Vegas. The day before the show, get home and they realize, how do we edit this? And so they're doing some research, how to edit 3D, and they found our software. And they downloaded it. And we'd only just launched it at the time. And they edited their trailer, which was running on at their booth. They had the 3D display, and it was just Nick Woodman hooting around in his car. And it looked really good. And so we walked by and we said, oh, how would you do this? They go, oh, you're the Cineform guys. And a year later, they bought us, basically. They never bought that software. It was a 15-day trial, but they bought the company. Yeah.
That's a good outcome.
Yeah.
So 3D's been a very good feature of the GoPros for some time now, both starting with the Hero 2.
Hero 1
Hero 1, really.
Yeah.
And now through to the 3 Plus.
Yes.
So, and GoPro's been experimenting with all sorts of strange things. I mean, the cameras are used in all sorts of weird and wonderful locations. What are some of the more weirder ones you've seen them being used in?
Oh, I mean, I guess nothing surprises me right now. If they've got this great clip of a pelican wearing a GoPro, but it's looking back at its head. They strapped it to its beak, and that wasn't done. We're careful of the animals that we mistreat. But always this was a rescue, and they had been teaching it to fly, and it became like a pet, and it didn't mind. So there's a whole bunch of really interesting places where you would never see a camera. But I think probably more related to what you're doing here at the Hive, some of the experimental imaging things that GoPro's been doing. to do 3D is the first step towards synchronized cameras. And it's always been our intent that some of the future of imaging is going to be multi-camera. And when I first started with the company, the CEO showed up an image to me, which is, you know, 1 camera, 2 camera, 3D, or then you can split it apart. We don't do an integrated 3D system because we want people to shoot 3D when they want to shoot 3D and then have 2 different views when they're just doing 2D. And then there was a line for a 3. We actually have built and prototyped a 3-camera 3D system, so you can change it interocular.
You want to bring up the image, Josh? Ah, there we go.
Yeah, so this, I have that at my house right now.
Here's one we prepared earlier.
Yeah, and so the synchronization design, and we have built the synchronization technology that we don't know how many cameras it can run to, like thousands. We are imagining scenarios when you could put like cameras around a stadium and that they can build a photogrammetric model of everything that's happening in a stadium at video frame rates so that you can do virtual camera fly-throughs of the world that is created. Now, compute power does not exist. When we talked about how long it takes to generate some of those images there, but we know this will happen. And so we are not wanting to leave that technology behind. GoPro is not going to be productizing array. All these are our array technology solutions. So we have like a 30-camera array here. This was done for Ken Block's Gymkhana series, which he does extreme, you know, off-road or on-road, you know, crazy rally stuff. But we use Array to do a lot of extreme sporting events. But we are now working with various partners, people like Autodesk. We give them our lens profiles to make sure that when there's a public domain or public accessible tool called 123 Catch, or is it Catch?
123D Catch.
123D Catch.
From Autodesk, yep.
Yeah, and so we work with them to make sure that GoPro, because what was happening is people were doing, they were picking up things like this quadcopter here I brought in for demo that's actually, you know, it flies a GoPro, and they were filming around building sites, taking photos, and then using that to build 3D models of, so Autodesk was just getting all its GoPro content, and so they had to come to us to make sure that it looked good. And because the GoPro is so small, it makes it very easy to fly in you know, a toy quadcopter. You know, that's a $400 aerial remote control vehicle that people were then using to collecting all sorts of images. And related to what you're seeing over there is this little crazy rig there. This is something that I invented early on at my time at GoPro. They do a lot of time-lapse with motion, and this is normally done with a product called a Kessler crane. And it's a motion control, and they want the camera to move. It looks cool to have the camera moving when you're doing a time-lapse. And these are about $5,000 a unit. And when I heard that the media department would often put these on beaches to film the sunsets, and they have the, you know, or morning, or if worse, sunrise, and what happened is one time one of the guys who set this up fell asleep. The ocean comes in and washes the $5,000 Kessler crane away. And so I was discussing with the creative director. I says, well, what you need is something like this, just using toy train track. That whole rig does the same thing. There's this motion control, controls the speed. For the whole presentation so far, it's moved from the right-hand end to the center right now. So it moves very slow. And it's right now taking one shot every 2 seconds in 3D.
Smile, everyone.
Yeah.
Smile every 1 second, though.
Yeah. So now these are, our media department uses these all over the world, and there's one of these touring with the Rolling Stones. They put it down by the drummer and get really cool time lapses of him, you know, doing stuff. And I haven't made any money off that yet, but it's a fun idea. So I've got involved with the camera team, the media team, and it's way beyond what I've just did in software. But there are features on the cameras that came from Cineform, which is exciting.
So the cameras themselves and the company itself has come a long way, and you know, from the GoPro 1. I mean, now it's, you know, 4K resolution and much higher quality lenses, and you know. Yeah, we're not. Our competitors are sort of still in the HD world. We're sort of feeling there's a lot more to imaging that will be. And the frame rates, we're shooting 120 frames a second, and yeah, we're shooting 4K, but it's sort of at an odd resolution frame rate right now, just because of the availability of but we push the boundaries as far as we can go. One of the things that came from the Cineform side of things is that, like I said, we fixed the mistakes of camera companies. And and I was the technical liaison to a lot of the
the feature film world. In fact, because they would come through Cineform, and now I was at GoPro, they would come and ask me. So I sort of had this role informally. It wasn't ever part of my job title, is to work with the Hollywood community. And the biggest pain they had, and this is an example of what Technicolor, who's a finishing house, Technicolor used to be the film, but now they're a pretty successful finishing house, and they would be doing like 20 major episodic television shows for NBC, ABC, CBS, and so on. And they would ask whenever they got a new project, this is what are you shooting on? And it's Arri Alexa, Sony Genesis, or whatever the cameras were of the time. And they would have to say, are you shooting any GoPro? And the answer is always yes. There isn't a single television show today that isn't shot with GoPro somewhere. But of course, they don't think about it. That's the $300 camera. They've got this $50,000 camera that they're mainly shooting with, but they're shooting with 10 GoPros on something. Yes. The problem is that Technicolor had to know, because they had to suddenly go, well, don't shoot this mode. Originally, we didn't have 24p, and most of US television shows are shot at 24p. And so the default camera configuration was for NTSC, so they would shoot 30p, which is the worst frame rate to shoot when you're trying to do a 24p production. So they would tell all their clients to switch it into PAL mode and shoot 25 progressive. And this is not obvious for somebody shooting content in the US. And so we took all that feedback and developed a system that both got them 24p and got them the way they wanted. They had a lot of other problems. GoPro content developed out of camera is really eye candy, ready for YouTube. So that's what the consumer wants. It's not what a professional wants. So the ProTune feature that's on the camera is basically a professional mode that allows the bitrate increase, gives you 24p, gives you more control over the image, and gives you actually a cinema quality, wide color gamut, raw image. And none of our competitors have attempted to do that. And in fact, it's not even common in prosumer cameras. So it's really unusual that it's in our $400 line, the premium line has the ProTune mode. And that's been one of the most enjoyable things, that I thought I was going to be treated just as a software guy. But the way my role on GoPro is that I help fix the mistakes that potentially could happen in GoPro. We design the camera with the software ecosystem in mind. And I've actually recently taken on a new role in which we've actually added a lot more software engineers. That's a massive team of people in the company now. But I remain a software engineer in the camera group, which is very unusual. So I'm in the advanced technology group doing research into alternative imaging. The idea of array technology for image acquisition is some of the things that my group looks into and considers what will this do in effect. But we are a consumer electronics company, so we have to work out how will this eventually benefit our consumers. And there's the geeky optics guys and the ISP camera design guys, and then I represent sort of this is how the end users are going to use it, and try and work out how we can design software such that when we come out with some crazy new camera configuration, we want to make sure that consumers can use it and benefit from that. Professionals, absolutely. I mean, our 3D stuff is used in pretty much any professional 3D shoot uses GoPro 3D content. But we want to make sure that it is accessible to our mass market.
So in 2013, GoPro was awarded an Emmy Award for
Yeah.
the very convenient category of inexpensive, small, rugged HD camcorder. I think.
Well, they wanted to
That
give
was
us an
a lucky-
Emmy. They just had to work out what it was
That's
under.
right.
Yeah.
Yes.
That was I was actually at the Emmys. That was a lot of fun, and it was apparently the fastest any technology had ever gone from being in the market to being granted a technical Emmy. There was the people who were the SMPTE committee that created the spec 1920 by 1080. They were getting the Emmy at the same time. The guy who invented the Steadicam, who first shot it for those running steps in
Rocky, wasn't it?
in Rocky, he got his Emmy then. That was 40 years earlier he developed that. And so, yeah, GoPro is the fastest in the history, but they just realized it was, GoPro now is 60% of the US camcorder market or something crazy like that. It's over 50% of all cameras, by volume, is GoPro. And that, we went 2 years earlier, people didn't know who we were. I didn't know who GoPro was when they first contacted us. So it was just not even in our...
Not on your radar.
Not on our radar.
Yep.
Yep.
Some audience questions. When's the GoPro 4 coming out? And also tonight's lotto numbers.
Yeah, they probably come together.
But are there any questions? Seriously, any questions from the audience?
So you talk about processing power required for some of these matrix cache systems. What sort of power are you looking at?
Well, right now, we mostly do linear array when we have a strip of cameras. I think we've done up to 150 cameras. Often they're pointed all at the one nodal point, and that helps because we know that Sean White's going to do some ridiculous flip, and we have and it's handheld array. Although 150 cameras is not. The 50 camera rig is handheld, so they can. The processing on that is mainly actually a stabilization technique. So that's pretty light. When you're dealing with the two-dimensional array stuff, you're trying to build a photogrammetric model and basically building a 3D world. And then you're going to do all your post-zooms, focus pulls, and stuff like that. And I mean, I think right now we're looking at for like a 4x4 or minutes per frame of compute time. But it's actually getting practical. Here's why it's becoming practical. I do believe this will become the way, certainly some epic effects moment in a feature film will be shot. Instead of having your primary cameras and a few other, they often shoot now with a primary camera and 2 or 3 other cameras to do the 3D models, to work out how to, because they're going to put it all and do a lot of things in the computer. But if you had an array of, say, a 10 by 10 array of cameras, now compute time would go up exponentially. But the compute time's getting faster. And as well, you used to shoot film, and you wouldn't see anything. You'd have to go and send it to get developed. And that's really the same process that's going to happen again. You wait, you've got the huge finishing moment of your movie. You shoot it with an array of cameras, and then you go and get it developed. And what actually happens comes back as a 3D model for the world that then you can do with your camera fly-throughs. And these are super resolution, so you can bring the camera in closer virtually. And if we would have an array of cameras shooting 4K or and shooting at a high frame rate, well, just 24p is efficient sometimes, we can build. So I do believe this is probably within, I think the first feature film that will be using this would be within 18 months. But that's just my personal perspective on it. And I hope they use GoPros. We're trying to make that the case.
Yeah, well, the 3D reconstruction is something we're actively working on in the Hive, and it's a very fast-moving area.
Yep.
So, yes. Question down the back from Julian Flack.
Yeah, it sounds like a little bit moving away from the consumer space into the professional space. Like multi-camera, 2 cameras, I think, just about sort of prosumer, but multi-camera, can you do that in the consumer space?
Well, the CEO, the fact is that we did reintroduce 3D with the Hero 3 Plus. We had a technical reason we didn't introduce it with the Hero 3, otherwise we would have had continuous 3D. We know that the market in 3D is not huge, but it's important to make sure that we are on the forefront of any kind of imaging stuff, because we don't want to be hit by someone doing some crazy multi-camera stuff that is just the newest thing that they've solved for consumers. We are continuing the research in that area. We're not doing the kind of 500 PhDs of Google kind of stuff, but we want our camera technology to be applied to that sort of research. But multi-camera is desirable for GoPro. The little remote that comes with the Hero 3 Plus can control up to 50 cameras simultaneously. And there is videos like of a skateboard friends. There's a guy who has 7 cameras on him, and he's just skateboarding, and he has one under and he has one on his knees and his elbows and stuff like that, and cuts together these things using the remote to start them all simultaneously, and so it makes his editing easier. The nature of GoPro is it's a mounted camera, so you're not using it. You're not pointing and shooting like a regular camera. You're not looking through a viewfinder. There is no viewfinder. There's no screen on the back. You mount the camera to get an angle, a perspective that you could not get with any other camera. But that only gives you one angle. So we are successful in another way is that Canon will sell you one DSLR, and then in about 4 years' time, maybe the imaging technology's got to you buy another one, and then you don't use that one. Whereas GoPro, our users tend to buy cameras multiply, and then they use all the cameras simultaneously. They have a Hero 1 and a Hero 2 and a Hero 3 and a 3 Plus, and they will often use them all together. And so we want to enable that even more so than we have today. That's another area that's in my, how do we make multi-camera editing easier? The people who are doing it right now are kind of more the prosumers or really enthused, but they're still passionate in whatever their activity is, and we absolutely sell multiple cameras, and that's a big part of our business. And that's another reason we're doing so well, is because we can sell more than one camera, that's even the same model, to the user, because they can benefit from it.
Well, thank you so much, David, for joining us. It's been fascinating to hear the story, and yeah, keep on doing fun stuff.
Thank you. Thanks.
Thank you.